We're going to look at revising Chapter 2 and covering some algebra, including the index laws, factorising, quadratics, expanding double brackets, just to name but a few. So here we have our main index laws. Basically, you need to remember when we're multiplying the same base, so x to the m times x to the n, we add our powers. So, for example, if I had 2 cubed times 2 to the 5, I could simplify that to 2 to the 3 plus 5, which would be 2 to the 8. When we're dividing the same base, we would subtract the powers. So if I had 2 to the 5 divided by 2 squared, simplifying that, we would subtract the powers. So we've got the same base, both are 2's, subtract the powers would give us 2 cubed. Now if we're simplifying it, we would just leave it as 2 cubed. If we were asked to calculate it, we would work it out. So it would give us 8. In this example, when we've got a power outside bracket, we apply the power n, multiply the two powers together. So for example, if I had 2 cubed all to the power 4, I would write that as 2 to the 3 times 4, which would be 2 to the 12. What you must remember is that if, however, I had something like 2x cubed all to the power 3, I would apply the power to the 2 as well. So that would be give us 2 cubed x to the 3 times 3, which we could write as 8x to the 9. An important one there to remember. Going back here, x to the power 1 is just x, so 2 to the power 1 would be just 2. And anything to the power 0 is 1. So 2 to the power 0 would be 1. And that is something they like to catch you out on. And you might see that in this context as well. So anything to the power 0 would be 1. Another important one to remember. Here we have some examples. So we've got to remember we multiply those two together. So 3 times 2 will give us 6. So we're multiplying here, we're multiplying the same base, so both terms have got an A in. So we add the powers, and 5 plus 6 would give us 11. So that would become 6a to the 11. In this question here, we would divide the coefficients first. So 16 divided by 4 would give us 4. Both terms have got an A. We're dividing, so we subtract the powers, and 10 minus 3 would give us 7. Here, this is a bit like the example I did on the last slide. I would write that as 3 squared, a to the 4 times 2, which is 8, and then simplify that to give us 9a to the 8. With this question here, I would write that as 2ab all to the power 5, and using the same rule as I did in the previous question, that would give us 2 to the power 5, a to the power 5, b to the power 5, and 2 to the power 5 would give us 32, a to the 5, b to the 5. Now have a quick go at these, pause the video and then check your answers to see whether you have got them right or not. And if not, where have you gone wrong, and make sure you correct them. So here we're multiplying the same base, so we would add the powers. So we would have a to the 3 plus 5, which would be a to the 8. Here we've got the same number, so the same base here is 4, so we're going to have 4. We're dividing the same base, so we subtract the powers. 6 minus 3 will give us 4 cubed. It does say simplify. Here we're going to multiply the 4 times 3 to give us 12. We've got the same base here, c, and we're multiplying, so we add the powers. So that would give us 12c to the 12. Here we're dividing. 12 divided by 4 is 3. Both terms have got p and we're dividing, so we subtract the powers. So our answer will be 3p to the 4. And here, put a power outside, so we'd have 3 cubed, p to the 2 times 3, q to the 3 times 3, which would give us 27 p to the 6, q to the 9. 9, no, not q. Okay. Now here we've got to remember that a negative power means a reciprocal, so 1 over. So if I had 2 to the minus 1, I would write that as 1 over 2 to the 1, which is a half. If I had 3 to the minus 2, I would write that as 1 over the positive 3 to the positive power, so 1 over 3 squared, which would simplify down to 1/9. If I had a fraction, so 2/3 to the minus 1, basically we flip the fraction and make the power positive. So that would just be 3 over 2. And if I had 2/3 to the minus 3, I would flip the fraction, 3 over 2, make the power positive, and then simply apply the power to each number in the fraction. So 3 cubed would give us 27 over 8. So here's some questions you might like to have a go at. So pause the video and then check your answers. So 4 to the minus 3 we could write as 1 over 4 cubed, and this would give us 1 over 64. In this question here, I would apply my rules for powers first. So I would say, well, that would be 3. I'm multiplying the same base, so I add the powers. Minus 3, add 2, would give me 3 to the minus 1, which would be 1/3. And similarly with this one, we're dividing the same base, so we subtract the powers, so minus 4 minus 2. So you've got to watch your signs with these ones, which would be 6 to the minus 4 plus 2, which is 6 to the minus 2, which we can write as 1 over 6 squared, which is 1/36. And the last one, I would apply my rules. So minus 1 times 2, so I'll multiply by the power on the outside, which would be 3 to the minus 2, which negative number means 1 over 3, but positive 2, which would be 1/9. So hopefully you got those right. Here's another slide for you to have a go at. It's asking you to write these as powers of 3. So pause the slide and see how you get on. So 9 is a square number. I know that could be written as 3 squared. 81, 3 3s are 9, 3 9s are 27, so 3 to the power 4 will be 81. Anything to the power 0 is 1. So that would be 3 to the power 0. Now, if we think of this, 1/3 we can write as 1 over 3 to the 1. It's not a power of 3, that's still as a fraction, so bringing that 3 up, so bringing the power up from the denominator into the numerator makes it a negative 1. So 3 to the power minus 1. If I think that was meant to be a 9th. So thinking about 9, I can write that as 1 over 3 squared. My power of 3 is in the denominator, so if I bring it up, I would make it a negative power, so 3 to the minus 2. That only works if you've got 1 up there. So 81, well, I know that 3 to the power 4 is 81, so I can write that as 1 over 3 to the power 4. I bring the 3 to the power 4 up and make it negative. 1 over 27, well, I know that 3 cubed is 27, so bringing that power up into the numerator makes it negative. And 243 would be 3 to the power 5, and bringing the power 3 up into the numerator makes it negative. Chapter 2 also covers some algebra, which we've done a lot of recently, and you're all really good at it. So just a quick recap, everything on the inside of the bracket is multiplied by the number on the outside. So I would multiply those to give me 3a plus 3 2's are 6 plus 2 times a is 2a minus 2 5's are 10, and then I would simplify. So 3a plus 2a would give me 5a, and 6 minus 10 would give me minus 4. On this one here, 2 times 4x is 8x, minus 2 3's are 6, minus 3x. Now here we've got minus 3 times minus 4, so it's going to become a plus 12. Simplifying, 8x minus 3x is 5x, minus 6 plus 12 is plus 6. Don't forget to multiply every term inside the bracket by the number on the outside and check those signs. Now we used FOIL to help us expand double brackets. So F being the 2 first terms, O being the 2 outer terms, I the 2 inner, and L the 2 last terms. So following that through, x times x is x squared. 2 outer terms would be x times 3. Here are the 2 outer terms, so that would give me plus 3x. 2 inner terms plus 2x, and the 2 last terms plus 6. And simplifying through gives x squared plus 5x plus 6. Looking at this one here, following the same idea, 2 first terms, x times x is x squared, 2 outer terms plus 5x, 2 inner terms minus 4x, 2 last terms, watch those signs, minus 4 times 5 is minus 20, which simplifies down to x squared plus x, got 5x minus 4x, minus 20. A different colour. For this question, the 2 first terms, I will have a times a, which is a squared. Then 2 outer terms will give me minus 7a. 2 inner terms minus 3a, whoops, wrong colour. And the two last terms, what's your signs? Minus 3 times minus 7 is plus 21. So your final answer would be a squared minus 10a plus 21. Now with this question, remember you're squaring the whole bracket. So that means you've got an x plus 5 multiplied by an x plus 5. And then we can carry on as we have done. So x times x will give us x squared. Two outer terms will give us 5x. Two inner terms will be another 5x. And the two last terms plus 25. Giving us x squared plus 10x plus 25. Now, do not forget this. This is where they're going to catch some of you out. So just think carefully. Watch your signs. And don't forget you're always multiplying. Another common mistake is to, when it comes to multiplying the two last terms, people don't multiply, they forget and then add. So don't fall into that trap. You're only adding together at this stage when you're simplifying. So watch out for this one. So here's some these are basically follow the same principle. So using FOIL, but you've just got to remember your signs and also that we've got a coefficient effect. So in the first example, a 2x. So think about these, have a go and then check your answers. So two first terms. So I would have 2x squared, two outer terms. So that would give me plus 4x. Two inner terms plus 3x. And the two last terms plus 6. Which would simplify down to 2x squared plus 7x plus 6. Two first terms here, so we have 6x squared, two outer terms plus 15x, two inner terms minus 4x, two last terms minus 10. Simplify to give 6x squared plus 11x minus 10. And in the final one, it doesn't matter about where your x's are in the brackets, just follow the same principle. So two first terms will give us 8, two outer terms minus 4x, two inner terms plus 2x, and the two last terms minus x squared. So that will give us 8 minus 2x minus x squared. So there are three answers. Work methodically, check each thing you're doing and watch your signs. So when factorising, you must ensure that you fully factorise the expression by putting all of the common factors outside the bracket. Now we know that in these examples here, we haven't, although we've got quadratic, so we've got an x squared, we've only got two terms and we're adding, so we haven't got the difference of two squares. And in the other questions, we've only got two terms. So we're only going to be factorising with one bracket. So if we look at 5x squared plus 10x, the highest common factor of 5 and 10 is going to be 5. The highest common factor of x squared and x is x. So we have 5x outside the bracket. Look at our first term. We need 5x squared. So we've got 5, we've got an x. We need another x to make it x squared when we multiply. When we look at the second term, we've got 10x. So 5 times 2 will give us the 10, and the x is already outside the bracket. So that becomes 5x bracket x plus 2. Looking at this second example, let's deal with the numbers first. So we've got 6 and 3. The highest common factor of 6 and 3 is 3. Looking at the A's, both terms have got an A. The highest common factor of A is A. And both, so only, and that's all that the letters, they're the only letters both terms have in common. Right, so 3A is our highest common factor. So we've got 3A outside the bracket and we need 6. So 2 times 3 will give us 6. Looking at 6AB squared, I've got the A out already, so I don't need to worry about that. And I need to have a B squared. Minus, looking at 3ABC, I've got 3A already outside the bracket, so I need to put BC on the inside. 35x to the power 4y minus 28x squared y cubed. So I look at my 35 and the 28 first of all. The highest common factor of that is 7. Then I check my x's. We've got x to the power 4 and x squared, so the highest common factor is actually x squared. And then checking out, both terms have a y. The highest common factor is just y. Right, so looking at my first term here, I need 35. So 7 times 5 will give me the 35. I need x to the power 4, I've got x squared. So I need another x squared to give me x to the power 4 altogether. And here I need a y, and it's already outside the brackets, I'm okay. Minus. Looking at this now here, I've got 28x squared y cubed. Well, 7 times 4 will give me the 28. So I've got a 4. I need x squared, and it's already outside the bracket. That's fine. I need y cubed. I've got 1y outside the bracket, so I need 2 more. So I need y squared on the inside. Here's another little one for you to have a go at if you pause a video and see how you get on. Right, when dealing with this, I'm going to look at each of my terms. I've got a 4, 2 and a 6. So the highest common factor of 4, 2 and 6 is actually 2. So I know I'm going to have 2 outside the bracket. Each term's got an A. I've got A cubed, A and A squared. The highest common factor is A. And B, B squared, B cubed. The highest common factor is B. Now go to my original expression. So 4A cubed B. So I've got the 2 outside the bracket, so I need 4, so 2 2's are 4. I need A cubed, I've got 1 outside the bracket, so I'll have an A squared inside, so that makes 3 altogether. I need a B, I've got the B outside. Let's go to the second term. I need 2AB squared, well the 2's already outside the bracket. I need an A, that's already outside. I need a B squared, I've got 1B outside, so I'm going to put plus B inside. Minus, going to my last term, 6A squared B cubed. I need 6, I've got 2, so 2 3's are 6. So that can be 3 there. I need A squared, I've got 1 outside, so I'll put another 1 on the inside. I need B cubed, I've got 1 outside, so I need 2. I need a B squared. So there is our expression fully factorised. Here's a little problem for you to have a go at involving algebra. So pause the slide and see how you get on. So we know we've got a rectangular box. We know that the volume of a rectangle is length times width times height. And we've been asked to find and simplify an expression for the volume of the box. So for A, I would say that the volume, I'll take each of my 3 dimensions. So I've got x plus 5 multiplied by x multiplied by 7. So if you like, x times 7 will give me 7x multiplied by x plus 5, and then expand the bracket. So that would give me 7x squared plus 35x. So this is how you show all your working out. Look at what you're dealing with. Volume, rectangular box. First thing you should do, write down that formula and then substitute in what you know and work from there. It then says find and simplify an expression for the total surface area inside and out. Okay, So the surface area, we've got 5 faces. So if we work out the area of the outside of the shape and then multiply our answer by 2, we will get the total surface area. So this face here, so I'm going to have a 7 times an x plus 5, and then I'm going to times that by 2 because it's going to be the same as the face opposite it. So that will give me 14x plus, well, 7 5s are 35, times 2 will give me 70. Then I'm going to do the other face. So that face, I'm going to have 7 times x, which is 7x. Then multiply that by 2, which is the same as the face opposite it, which will give me 14x. And then the area of the base, there's only one base, so that is going to be x times x plus 5, which will give me x squared plus 5x. Now if I add all those together, give me the surface area outside the shape, so adding that up gives me x squared. 14x plus 14x is 28x plus the 5x, which is 33x plus 70 centimetres squared. So that's the outside of the shape, so the total surface area outside and inside is going to be 2 times that. Okay, so it's going to be 2 times x squared plus 33x plus 70 centimetres squared, which is 2x squared plus 66x plus 140 centimetre squared. Here's some examples for you to have a go at, just recapping what we've done so far. Pause the slide and then check your answers. So for this one, 2 first terms, 2x squared, 2 outer terms plus 6x, 2 inner terms minus 2x, 2 last terms minus 3. So you should have got 2x squared plus 4x minus 3. This one, I would just write out the 2 brackets so I don't make a mistake. So 3x minus 1, 3x minus 1. 2 first terms will give us 9x squared. 2 outer terms minus 3x. 2 inner terms minus 3x. 2 last terms plus 1. Overall answer, 9x squared minus 6x plus 1. And finally, 2 first terms, x squared, 2 outer terms plus xb, bx, 2 inner terms minus ax, 2 last terms minus ab, and we can't simplify that any further. So there we go. Hopefully you got those right. If not, go back, check your answers, and just be careful of your signs. Work through things methodically, show all you're working out, do things one stage at a time until you get to your final answer. Now we have a quick recap on factorising, so putting a quadratic back into brackets. So we're looking for 2 terms that have a product of minus 8 and a sum of 2. So you go through your different possibilities. So I'll make a little table here. I can have 1 times minus 8, or I could have minus 1 and 8, but neither of those add up to give me 2. I could have 4 times minus 2. Oh, that one works. 4 times minus 2 is minus 8, and 4 minus 2 is 2. So as I'm working through, that one ticks the boxes, so that's fine. So that means in one bracket I'm going to have a plus 4, and in the other bracket I'm going to have a minus 2. And you can double check to make sure it works out. In this example, second one, I want two numbers with a product of minus 3 and a sum of minus 2. So again, we work through things methodically. I could have 1 and minus 3, or minus 3 and 1. When I look at those two, the first one actually works, because when I add them together I get the minus 2. So in one bracket I will have plus 1, and in the other bracket I'll have a minus 3. And check it to make sure it works out. Simplifying algebraic fractions. Now it's really important when you've got anything like this is to try and factorise your fraction first. So looking at the numerator here, I can take out a factor of 5. So that inside the bracket that would give me 5x plus 3, and then divide by 5. So once I've done that, I can see that the 5 in the numerator will cancel with the 5 in the denominator to give me a final answer of 5x plus 3. Again, in this second example, I can take my highest common factor is going to be x. So that'll give me x on the inside plus 3 all over x, and I can cancel out my x in the numerator with the denominator to give me x plus 3. Please do not fall for the trap. This is so wrong. You cannot say, okay, well, I'll cancel out a 5 with that. Okay, or I can cancel out 1x. Just I would factorise first and don't fall into any traps. So we'll move on to adding and subtracting algebraic fractions. So we add or subtract fractions in the same way as numerical fractions. We need a lowest common denominator. So I can see here the lowest common denominator here would need to be 6. So I've multiplied the denominator by 2. So I need to do the same to the numerator. So that would give me, I'm going to put it in brackets as well. So 14x plus 6 minus, and to make this 6 I've multiplied by 3. So I do the same to the numerator. I need to multiply that by 3. And again I'll put this in brackets. So that'll give me 12x minus 15. So now I'm going to write that as 14x plus 6 minus 12x minus 15, and that's all over 6. Simplifying through, I'll say 14x minus 12x will give me the 2x plus 6. I've got a minus here, so minus 15 will give me 6 plus 15, and 6 plus 15 is 21, and that's all over 6. I can't factorise a numerator, so I leave that as my answer. In this second example here, 3x minus 1 minus x plus 5, I've got my lowest common denominator here. I've got this one over 4, so the lowest common denominator is actually just going to be 4. So to change this first fraction for it, well, it stays the same. I'm just going to put 3x minus 1 in brackets, so that stays the same. Minus, now to make this 4 in the denominator here, I've multiplied by 2, so I multiply the numerator by 2. So that'll give me 2x plus 10. Again, I've put that in brackets. And that will give me in the numerator 3x minus 1 minus 2x minus plus becomes a minus 10. So watch those signs when you're expanding the brackets over 4. And simplifying, collecting like terms, 3x minus 2x will give me x, minus 1 minus 10 is minus 11 over 4. I cannot factorise a numerator any further, so that would be my final answer. In this final example, my lowest common denominator in this case is going to be, in the first fraction, 5 2x plus 3. So to make this first fraction 5 2x plus 3, I've multiplied the denominator by 2x plus 3. So I do the same to the numerator, 2x plus 3. And you can actually see that those would cancel out, the two brackets leaving us 4/5. If we look at the second fraction, okay, I've made that 5 2x plus 3, so I've multiplied the denominator by 5. So I do the same to the numerator, I multiply that by 5. So in fact that becomes 2 times 5, which is 10. Right, so now my denominators are the same. I'll write that as 4 bracket 2x plus 3 plus 10 over my 5 2x plus 3. I'm not going to expand my denominator just yet, I don't need to, because I might be able to simplify further at the end. So expanding my bracket there will give me 8x plus 4 times 3 is 12 plus 10 over 5 bracket 2x plus 3, which in the numerator will give me 8x plus 22 over 5 bracket 2x plus 3. And factorising the numerator will give me 2 bracket 4x plus 11 over 5 bracket 2x plus 3. And I can't simplify anything any further, so we leave our answer as that. So looking at this, I look at my lowest common denominator. So I want 4p squared and 4p squared. So I've multiplied, to go from 2p to 4p squared, I've multiplied by 2 and another p. So I've got to do the same to the numerator. So I've got to multiply by 2p. So that will give me 6p in the numerator. And you can try it out, it would all work out. And this denominator remains unchanged, so we'll stick with the 5 up there. So simplifying through, that will give me 6p plus 5 in the numerator over 4p squared. We cannot simplify this any further, you have to leave your answer like that. We cannot just cross out 1p in the denominator with only one term in the numerator. You would have to do the same to every term that you're adding. So if we were going to cancel out a p, we'd have to have another p on this side of the numerator. Okay, on the plus side. You cannot just cancel out part of an addition sum in a numerator. Okay, so you don't do that. So looking at this first one here, we want the lowest common denominator. So don't be put off by there being two fractions. I like to put brackets around, it just makes things easier. So I need both fractions to have an x plus 3 and an x minus 1 in the denominator. So on this fraction I've multiplied the denominator by x minus 1 to give me this, so I've got to do the same to the numerator, x minus 1, plus the second fraction is also going to have an x plus 3 and an x minus 1. It's got a 3 there. The x minus 1 was already in the denominator, so I've multiplied by x plus 3, so I've got to multiply the numerator by x plus 3. Then simplifying through, expanding the brackets, that will give me 5x minus 5 plus 3x plus 9 all over x plus 3, x minus 1. And simplifying the numerator will give me 5x plus 3x is 8x, minus 5 plus 9 is plus 4, over x plus 3, x minus 1. And I can see I can factorise my numerator, so I can take 4 outside the bracket. That'll give me 2x plus 1 over x plus 3, x minus 1. I can't cancel out any of my brackets, so I leave that as my final answer. I would suggest not to expand, don't expand expressions in the denominator, just leave it as it is. Again, here in this, we've got x minus 3. I'm going to put brackets around those because I prefer them. So the first fraction is x minus 3, and we're going to multiply it by x plus 4. So I'm going to do the same to the numerator. I've got to multiply that by x plus 4. And we're subtracting here, so I think, uh-oh, we've got signs to watch out for. This has already got an x plus 4 in the denominator, so I'm going to multiply it by x minus 3, and then multiply the numerator by x minus 3. Expanding the numerator will give me 4x plus 16 minus x squared minus minus 3 becomes plus 3 all over x minus 3 x plus 4. Simplifying that through will give me 14 plus 7x minus x squared all over x minus 3 x plus 4. Now at this stage you'd have a look at the numerator and see if you could factorise it. We can't factorise it, so we'll leave that as our final answer. So when we're multiplying fractions, we always want to try and cross cancel, so any term in the denominator can be simplified or cancelled down with any in the numerator. That's only when you multiply. So I can see here I can divide both this term by y to give me 1, and that one will leave me with y squared. I can cancel out an x in the denominator there with 1 in the numerator there. I can say 3 divided by 3 is 1 and 6 divided by 3 is 2. And when we've done that, I'll just write this out a bit underneath. So that gives me 1x over 1 multiplied by y squared over 2. And we then multiply across. So multiplying numerators will give me x y squared and 1 times 2, which is 2. Now when we're dividing fractions, we've got to remember our rule. The first one, fraction stays the same. So that gives me 2y squared over z cubed. We change the sign and we flip the second fraction. And then we can cross cancel where if possible. So looking at our numerator here, I've got a z here and cancel out with one of the z's there, so that leaves me with z squared. I've got 2, cancel out with the 8 there, so that gives me 4. I could cancel out y there, which will leave me with just a y in the numerator. I could cancel out an x there, which will leave me with an x. So what I'm left with, if I write this out underneath, now I'm a firm believer that if you've got an expression, you need to try and factorise first before you do any simplifying. So if I look at this first fraction, I can see here that the denominator could be simplified, factorised to give me 3 bracket x plus 2, multiplied, and I put a bracket round this bracket x plus 2 because it's one term, over x squared. And we can see quite easily now that we can do some cancelling out. So I can cancel out my x plus 2 with the x plus 2, and I can then cancel out one of the x in the denominator with 1 in the numerator. Okay, so I can then multiply through, so that becomes 1 times 1 in the numerator and 3 x in the denominator. Looking at this fraction, we've got 3 over x times, flip the fraction, x cubed. Now I can see at this point I can factorise the numerator here to give me 3 bracket x minus 2. And again, we can simplify a 3 here. 3 divided by 3 is 1. And I can also cancel out an x with one of those to give me 2. And now I can multiply through my numerators. So 1 times x squared will give me x squared, and 1 times x minus 2. So I have x squared over x minus 2. Now I've covered a lot of work here, and they're the main parts of the main bits we've covered in chapter 2. So there's quite a lot there with algebraic fractions, factorising, all things that you should be good at, but you need to pay attention to detail and think things through carefully and work through questions methodically. Now I will be setting some work on Insight to help with your revision, and there will be an online skills test for you to do after you have done everything. So the idea is to get the best score you can first time round. So hopefully this has made sense. If there are any areas you are unsure of, then you must go and practice them. Go and do some extra questions until you feel confident with them.